We will be discussing the first question. That is the Coldplay tickets. Yeah. So recently we had an event that's Coldplay. So based on that we have a question today. That's really interesting. So what the first question says that that is like you are a person. So you have basically n friends with you. Okay, and the each ticket of the Coldplay costs almost around 5,000. Okay, and what we have been asked is that we have to find the total number of total amount that we need to pay. Okay, so what exactly you have to think in this point is that first, I think it's pretty clear that we have n friends, including you. It's n plus one. Okay, next, each ticket is 5,000, and now we have just asked this is that what is the total amount of ticket. So it's just basic mathematics that we will just multiply the whole n plus 1 multiplied by the total the single ticket cost, obviously. So whenever we are just going through any questions, we have to just make sure that constants we are reading it very thoroughly, because sometimes it's maybe, but in this case there would be would not be any issue. So just the n is in the range of 1 to 5, so obviously there's no issue. So let's take some sample test cases to like better understand. So suppose if, for example, say you considering as chef only. So if chef has only one friend, so how many friends, like how many total members are there? Two. So that's they are saying that is two multiplied by 5,000. That is ticket for like cost for one ticket, and overall we are getting what 10,000. And then again, let's take another example. Let's say five. Okay, five friends of chef are there. So overall what n plus one, six, and 6 multiplied by 5,000 is 30,000. So again, that's 30,000. So it's a basic simple formula. Like over here written is that simply you have to do is n plus 1, and all this thing multiplied by the rupees the amount. So in this case, the amount was obviously 5,000. So just put over here 5,000 and n plus 1 just value change. So that's the basic thing you have to understand over here. Let's just go through once by with the code as well. So just I have mentioned over here is the n plus 1 multiplied by 5,000, and that's all. So we are taking just first we are taking the n as an input, because this time we have given us n like obviously as an input. Over here in the question it was mentioned that n would be 1 2 3 whatever till 5. So we're taking then input n, and then finally just we are putting out like the whole n plus 1 into 5,000. So it's a basic question. So there's nothing much to think. Just one thing you have to take care in this question was this plus one only. Other than that, it was a basic question only.
Okay. So in this question, Sushil is a diabetic patient. He is only allowed to eat at most K calories in a day. However, he likes to eat a lot of sweets. So there are n sweets in front of him, and the ith sweet has a calorie count of AI. So basically, इतना part is basically ये दिया है कि we have an array and of size n, and each element of the array is represented by AI. Okay. So Sushil will eat the sweets in order. That is, he will start from the first sweet, second sweet, and then third sweet, and so on. So the ordering is important. This line tells us that the ordering is important in this question. Uh, Now the next line, if eating diet sweet would take him over his daily calorie limit, he will not eat it and he will not eat any further sweets. So basically, uh, if I have exceeded my calorie limit, then I cannot eat any more sweets. Till then, I can eat as many sweets as I want. So, like, what is the maximum number of sweets that I can eat without exceeding the calorie limit? Again, let me show you the constraints. Okay, so here, um, the constraints are pretty simple. T is going till 100, n is going till 100. The array values are going till 100, and the maximum value is till 1e4 for the value of k, which is the limit size of the calorie. So, uh, okay. So here, we have to find out the maximum sweet. So what we can do in this question is basically take the sum or basically the prefix sum of the elements from start of the array, and we will check at each point whether we have exceeded the limit or not. At the point, this point where we have exceeded the limit, we will stop and we will go out of the loop and we will print the कि हमने कितना sweets खाया है. We can either directly use the index for that, or we can use a new counter variable for that. Let me just show you with an example. So okay. So here we have 4. So first of all, the 4 is the size of the array. So this is the size of the array, and the values of the array are 5, 2, and 5, 2. And the maximum, this is basically my limit, or the maximum calories that I can take. So here, uh, at first I will eat 5. So the sum will become 5. Then I will eat 2 more. So the sum will become 7. It is less than 10. I can continue. And at this point, my sum is exceeding 10. So 7 plus 5 is 12. It's exceeding 10. So at this point, we break out of the loop and we basically return the index value at which we broke out. Now there is an edge case that what if we can eat all the sweets, right? So if basically if we are just following this algorithm, then uh, we might basically not. Let me show you with the help of the code. So just a minute. Yeah, so here um, I guess you can see the code. This is in Java, but it's just focus here because this part is irrespective of any language. It will like this part is basically I'm taking n as input, then I'm taking limit as an input, then array as an input. So this is all the input part. Then what I'm doing is basically I'm initializing a variable sum. I have taken it to be long. You can take it to be integer as well. That's not an issue. I'm taking a variable. What is the maximum number of sweets that I have? I'm iterating from the start of the array and I'm taking the sum. At each point, I'm basically making sure that if my sum has exceeded the limit, the maximum number of sweets that I have that I can eat, I will assign it to I. The reason I'm assigning it to I is because when I'm exceeding the sum, I cannot eat that particular sweet. So the I index is basically number of sweets that I had the sum till which I have taken the sum minus one. So that is why I'm adding or assigning it with the value of index, and I'm breaking out of the loop. Now this edge case is that if the calorie of all the sweets does not exceed the limit, then in this case, this part will never happen. So in that case, my answer will come out to be zero. The maximum number of sweets will come out to be zero, which is wrong. In that case, my maximum number of sweets should be n. So this edge case had to be handled, and then we can just print the maximum number of sweets. So yeah, this question is basically uh, as simple as this. So any doubts, guys, on this regarding this question?
Sir, is it necessary that the sweets taken in are in that order? For like example, if 5 to 5 2 is there, is it possible that 5 2 and then we'll take the last element?
Y Yeah, so that's why that is mentioned in the question. Let me show you. Uh, it's in the same. So let me show it to you here. That he will start from the first suite, then the second suite, then the third suite. I understand what you are asking is basically कि अगर मुझे maximize करना है, then I could have sorted it and greedily taken the minimum number of suites and added that. But यहाँ पे order is important. That's why I wrote in the doc that ordering is important. It's mentioned in the question in bold that Sushil will eat the sweets in order. Okay.
Okay, sir, understand. Thank you.
Okay. Any more doubts? Okay. So in this question, add one or two game, we are basically given that. Okay, let me present it to you the Google Doc for that. So you will get to know the question better. Okay, add one or two game. Uh, okay, so let's move on to the next question. Add one or two game. Alice and Bob are playing a game. There is an integer x which is initially 0. On their turn, Alice or Bob can choose to increment x by either 1 or 2. The game ends as soon as x is greater than equal to n. Holds. When the game ends, Bob wins the game if x is equal to n, otherwise Alice wins the game. So the rules are pretty simple. We have a variable x which is initially 0. We can, at each step, I can make x is equal to x plus 1, or I can make x is equal to x plus 2. Okay. Now, if whenever my x is becoming greater than or equal to n, the game ends. Okay. So if my x is greater than n, then in that case, uh, uh, Alice wins the game. If x is equal to n, then in that case, my here Bob wins the game. So now there is one more important thing, that Alice goes first and the players alternate turns. So let's go to the first test, like the base case or the most easiest case, that if my n is equal to 1, then in that case, it's clear that Alice wins. So Alice wins. Uh, if my n is greater than 1, then we have to look for, like, obviously, as like the constraints were really really small, so you could have like played the whole game recursively and like found out key whether the solution exists, like who will win or not. But let's look at a better approach, which is like you can basically solve this question in constant time. The constraints were really small. The n ka value was like 4 from 1 to 10, so you can solve this recursively as well. But uh, let's look at this logical approach. So if n is equal to 1, we know Alice wins, right? Now, if n is greater than 1, um, you can pretty much be always sure that Bob wins. Now, how to deduce this, right? First of all, it is pretty much sure that if the game will end only if my x is at n or my x is equal to n plus 1. Now, why is this happening? This is happening because I'm always increasing the value of x by either 1 or 2. Okay. So the game will end when x is equal to n or x is equal to n plus 1. Now, if x is equal to n, my Bob wins, otherwise Alice wins, right? So for Alice to win, okay, Alice should play the game when my x is equal to n minus 1, right? This is the case. This is the only case when this should happen, so that for n greater than 1, Alice wins the game. But will this happen? The question is, will this happen? Let's think on it. So the thing is that this will never happen. And the reason is that for Alice to get x is equal to n minus 1, like Alice's turn to take place in x is equal to n minus 1, it means before Alice, it was Bob's turn, right? So before Alice, it was Bob's turn. So the value could have been n minus 2 or n minus 3. But now listen, if the Bob's turn at Bob's turn, the value was n of x was n minus 2, he could have increased the value of x by 2, right? So at this point, the value of x could have been increased by 2, right? To get to n. And in this case, Bob wins, right? because a pretty clear message is written in the question that they both play optimally. So Bob will never try ki I lose. It will never. It will always try ki I win, right? So at when there is n minus two with Bob's turn, it will obviously increase it by two to win, right? If it is n minus three, then what it can do is it will, if it does n minus 2, okay, by increasing it by it can either make it n minus 2 or it can either make it n minus 1, right? So now if it is making n minus 1 and it means that the next turn at Alice will be next turn will be Alice's turn and the value is n minus 1, so he knows that Alice will win, right? But he doesn't want Alice to win, so he will always make n minus 3 go n minus 2, and with n minus 2 Alice can now it is Alice's turn when x is equal to n minus 2. So with this, Alice will not make increase x by 2, because if it does, again x will become equal to n. So again Bob will win, right? So again Alice will make it x equal to n minus 1 by increasing this term by 1, and then Bob will win again by increasing it by 1, right? It's a really complicated mathematical stuff. So any doubts है तो पूछो, because this is pretty much basically the stuff that if n is 1, Alice wins. If it's greater than 1, Bob wins. Yeah, that's the code. Really simple. But like understanding this, the first point that the game will end if x is equal to n or n plus 1. And this will never happen, that Alice should play the game when x is equal to n minus 1, because Bob will always try to manipulate the game in such a way that Alice can never reach to this state. And if Alice cannot reach to this state, then Alice can never win if n is greater than 1. Okay. So any doubt?
Okay, Satyam, a quick question. You were telling about the recursion approach because the constraint is less. Can you brief that approach to them once again?
Okay, recursion. Okay. Let me tell that. That would be easier, honestly. Uh, because the constraints are so low. So recursive mein what we can do is basically we can have some states. Okay. The first state is the score. So the states of the recursion, we can have a score, and then we can have कि ये किसका turn, right? And we will return boolean value, and if finally the answer is true, then it means that Alice wins, otherwise the answer is false. uh, False, then Bob wins, right? And majority of the all the cases mein for n greater than 1 the answer is going to come out to be false. So how are we going to write this recursive thing? First of all, inside the function, let me just call this one. uh, I will have the current score. I will have this is which guy's turn. Then I will also have the value of n, right? So as to compare uh, what is my current score, and like how to compare the current score with the maximum value of n. So if my score has become equal to n, right? Then in this case, Bob wins, so I can return to be false. Else, uh, if my score has exceeded n, then in this case Alice wins, so I can return to true, right? Now I can take two Boolean variables. That is, the first one will be that I'm incrementing the score. That is, the score is basically the value x. Okay. So I'm incrementing it by 1 or I'm incrementing it by 2. So I will write both the possibilities. and depending on the result of the possibilities, I will return the answer. Right. So if uh, let me just take it increment with 1. So in this case, I will call this function by score plus 1, and the turn I have taken it to be integer. You can take it to be boolean because there are two players. If I am currently at so let me explain this part. So if my current player is Alice, I am taking it to be 0, or Bob Pilya, I am taking it to be 1. Okay. Now to change the player, I can just do 1 minus the current player. So that if it is Alice, 1 minus 0 is 1, so it will become Bob. And for Bob, I can do 1 minus 1, so it will become 0, so it is Alice, right? And n will go as it is. I can do the same thing for, but increment it 2, because I'm taking both the possibilities that I'm incrementing x by 1 or incrementing x by 2. Okay. So in this case, I will increase the score by 2. So now, if the turn is Alice's turn, okay, so if the turn is 0, then I can basically return if either of these, uh, if either of the path gives me the answer as true, it means that I have found a path which is giving me the correct answer, right? So because it is Alice's turn, so if any of the path is giving me true, I will return back true, right? So increment with 2, right? Else, if it is Bob's turn, then uh, I don't want Alice to win, right? So my both the paths, like whatever paths I take, uh, I will choose that path which will make Alice lose, right? So in this case, um, what I need to return is that uh, if my the next path is returning me false by increasing it by 1, and I'm increasing it by 2 as well. So if one of them is returning me false, then in that case I can choose that Bob will choose that path. Okay. And if both, so I will basically check which one of them is not returning out to be true. I will return that. So let me explain this part after writing this, or increment with 2. So basically, if I'm basically choosing that path which is going to return false, right? And in this case, I'm going to choose that path, any path which is going to return me true. Okay, because if I'm Alice, then I want myself to win. If I'm Bob, I want myself to win. So this is the approach, for the recursive approach, and this is the mathematical approach. So any doubts? Like, should I explain something more? No doubts. So we can move forward with the question.
All right, so I'll be beginning with this question. Okay, so question name is GCD and XOR. So here is the problem statement. You are given an array A of size n, and you can perform the following operations as many times as you want, possibly zero. And what we have to do is we have to choose integers L, R, and X such that L and R can coincide and will be lying between 1 and n, and also the X can lie between 1 and lesser than 2 to the power 30. And what you can do in those operations is you can select any I between L to R, you might be getting a guess that L and R are going to be indexes. Okay, so I will be lying between L and R, and what you can do is throughout that sub array that will appear from L to R, you can either set AI each element of that sub array equal to AI XOR X, or else what you can do is you can put all that AI, all the elements of this subarray equal to the GCD of AI and X. Okay, so these are the two operations that you are permitted in this question. And let's move forward. That is, choose a subarray A and an integer X, and either replace every element of the subarray with its GCD with X, or replace every element of the subarray with its bitwise XOR with X. Okay, and what we have to finally return is compute the minimum number of operations required to make all elements of the array equal to k. Okay, so I'll just give you a better example through the sample inputs that what the question is conveying to us. Let's say we are given an array A of size 4. Okay, and that array is 2, 6, 4, and 1. So what you can do is you can select any subarray. Let's say I select 6 and 4, and I do any operation. I can choose any x. Okay, so this is important. That question gives you freedom that you can choose any x. Okay, and you can what you can do is you can either take this subarray or this subarray or this whole array. You can take anything, and you have to either use AI XOR x, or you have to put GCD of A of I and X in that place. For example, if I choose L is equal to 1 and R is equal to 2, and I put operation of GCD and I choose an X, let's say 2. So what I will do is my array of 2, 6, 4, and 1 will get converted to uh, 2, 2, 2, and 1. Okay. Many of you might be not knowing about this operation XOR. So this is a little bit basic about bit manipulation. You will be further learning about in our CODEtronics classes. But I will just give you a brief about XOR operation. You must have done your electronics course, right? So what we do in XOR, we just flip the bits. The opposite bits should be different if it has to be a set bit. For example, if you have a binary expression of 5 as 101, and you have a binary expression of 7 as 111. So bitwise OR of 5 and 7 will result into this 1 1 will result into 0. Okay, and 0 1 will be 1, and 1 1 will become 0. So that's what you are going to get. All right. So that's what we are going to utilize in this question. And with GCD, you must be very familiar. GCD with the greatest common divisor. Okay, so we were on this question, on this sample test case, that on applying from L is equal to 1 to R is equal to 2, this operation of GCD with 2, what we do is we select 6 and 2, keep its GCD with 2 here, and we select then 4, keep its GCD with 2 here. Okay, so it transforms the array into 2, 2, 2, and 1. Now if we further select L is equal to, let's say we use the second operation, operation 2, and we select x is equal to 3 and L is equal to 1, sorry, L is equal to 3 and R is equal to 3. You can note one thing, that in the question we can have coinciding L and R. Okay, so L and R can have the same number in itself. So what we are going to do is we can select x is equal to 3, L is equal to 3, and R is equal to 3, and we are going to use XOR operation. Okay, so this array will further transform to 2, 2, 2, and 2, because as 2 XOR 1 XOR 3 is equal to 2. Okay, so now we have obtained the array which is identical, right? All the elements are identical, and what we were given in the sample case is 2. So we have converted this array to the equivalent array 2 2 2 2 in minimum of 2 operations. Okay, so this question is more based over critical thinking of how you are going to think and build up your thought process for this question. Okay, so let's discuss different questions, different cases for this problem. Let's say I name case 1. Case 1 is when you know that all the elements of your array are equal, right? Let's say we are given a problem of test cases, like we have 6 number of elements. We have to convert all of them into 4. No, and your array is 6 6 6. Let's say it is 4 4 4 4 4 4 and 4. So you know that all the elements are identical, and you need not perform any operation at all to make this array according to the question. I mean, converting all the array equal to k, right? So you can directly print out that 0 operations are required, and that is obviously going to be the minimum number of cases. I hope these things are quite clear. You people must not be having any doubt in this case. And if you have any doubts, you can directly interrupt me in between. Okay. So what's next in this? What is the case 2? Next case can be like you have any array. Let's say I will take any arbitrary array, 4 elements, where k is going to be equal to 2. Let's say k is equal to 1. Okay. And what you can do is you can take any array. Like we have 14, we have 23, we have 5, we have 10. One operation that you are able to think here is, can I take the GCD of all these elements with 1? Can you do that? Yes, you can do. You can select the entire array as your sub array, right? So what you will be doing is, you can take L is equal to 0, you can take R is equal to 3, and you can select X is equal to 1, and operation is take GCD with all elements of your sub array. Okay, so our array of 14, 23, 5 and 10 will transform to 1 1 1 1, and that's our required answer. So you can have an intuition, like we can either select uh, any array and we can take GCD with 1, we can convert them all to 1. So we are properly advancing to the actual intuition of this question. This thing was very important, that you can select x is equal to 1, you can select the entire array and convert it to 1 1 1 1, and that's how we do it. So one more thing you can analyze in this question is, I'm just saying one thing, like you can think about this, that the maximum possible operation, the maximum possible number of operations that you need to do in this problem is never going to exceed 2. But why? You need to think about this. Why am I saying this is, let's say you are given any array of 100 length, okay? Let's say n is equal to 100, and you have to convert all of them to, let's say, 53. All right. Now you will have many numbers like a1, a2, a3, and so on up to a100. Can I take the GCD with 1 for entire array? Yes, I can do it. In one operation, you can take GCD of all the elements with 1. Okay, so our array will convert to, like this is a100. This will get converted to 1111 up to 100 elements. Okay, now what I can do is, I can take I can consider any particular x. I can choose an x such that if I take the XOR of all these numbers which are 1 and identical and convert it to array. Let's say we have to convert 1111 in 53s. Alright, we have to keep 53 and all the 100 indexes. So what we can do here is, we can select a number, let's say 52. Okay, we will XOR 52 with 1, and you will realize that this XOR is equal to 53. Alright, so we can convert the entire array in the next operation in 53, sorry for that, 53, 53 and 53 entirely up to 100 elements. So one thing is like a thumb rule in this question, that you can convert in every question, you can convert the array to the required array in at most 2 operations. Okay, this thing is important, that at most 2 operations are required. All right. So what we have to find out is, we first of all figured out 0 case operation. Now only thing that is left is finding out all the 1 case operations. Like you have to just analyze your array, okay, and you need to find out, can I solve this problem by using only 1 operation? And if you are able to figure out that, you will be able to solve this question in within seconds. I mean, coding part is not that tough of this question. It's pretty straightforward. What all you have to do is just find out the first case where you don't have to do anything, and this is pretty straightforward. Like if all the elements are equal, and the next thing is find out if you can solve this problem in only 1 case, like by only 1 operation. Okay, so I'm naming it as case 2, where you have to find out if you can convert the given array into the required array in just 1 operation. Okay, and this is not a very hard work to do. You can consider various cases, like for example, if you are given n is equal to 5, n is equal to 5, k is equal to 2, and your array looks like 2, 2, 2, 2, 3, 3, and 2. So can you select this subarray and execute the XOR operation and convert this subarray to 2, 2? Then your entire subarray transforms to what? 2, 2, 2, 2, and 2. Right? So what you have to do is search for a subarray, okay, that is identical in itself, in entirety. Like it will be different from those of the case, but it should be equal inside of it. Let's say if I separate these two threes, okay, so this, we don't have to touch these two, we don't have to touch this terminal 2. What we have to do is apply an operation of XOR on these two threes, okay, and we will able to get our required answer. Okay, so this is the whole point of this question. Like, can you find out those type of subarrays if they exist in the question? All right, so there are some cases, like for example, case when you have to only use GCD. Okay, these are further sub cases in the second case. Case when you have to use only XOR. Now you people might be thinking about where we should use GCD in this question and where we should use XOR. So you must be getting a little idea. Like for example, if you have 2, 4, 6, 8, 18, etc., you cannot use any single number in XOR with this operation, in with these numbers, so that you reach to 2, 2, 2, 2 for all of them. But if you use GCD with 2, you will be able to convert this to 2, 2, 2, and 2 directly. So this is the major difference. Like if you are able to find a common factor of 2 in this array, then you are able to do it with GCD. However, if you are not able to find a GCD factor, then you will have to find, and you will have to go for the second subcase. Like you will have to find a particular X for which the XOR operation will work for us here. Okay, so that's the main point of this question. And more importantly, if you have to apply the second case, you will have to make sure that all the elements are equal in the subarray, maybe distinct than the k. Okay. For example, if I am given an array like 1, 1, 1, 4, 4, 4, 1, and 1, and my task is to convert this to all the ones. Okay. So this is required that we are keeping all the ones. Okay. And this is what we are given. Okay, so one thing I would like to ask you people, that can you convert this in single operation equal to the above array? And the answer is going to be pretty simple. Yes, we can do it. Why? Because we can select this subarray, we will XOR it with a particular x, and it will convert it to this subarray which equals to 1 in all of these three places. Okay, and you people don't have to really think about whether there exists any x or not. There always will exist an x, because if you think in terms of bits, okay, you can manipulate these bits, right? You can manipulate as much as you want. You are given with a number, you have to just flip 0 and 1s and convert it to a different number. That's not a pretty difficult task, right? You can directly do that. So this is the point of this question, that if you have to apply the second case, you will have to find a subarray inside and all those elements should be equal, or else if you are going to use GCD, you'll have to find out for these cases. Okay, so that's the whole point of this question, and this is all about this. And if it is not falling in these two cases, then we are for sure going to keep things in the third case, where what you can do is you can solve the question in a straightforward manner, like you are going to force your solution here. Why I'm saying that you have to force your solution is, just let's say we are given any array of, let's say, size 12. Let's say size, a small size will take, n is equal to 6, okay, and k is equal to 5, and you are given the array of 12, 33, 33, 112, 43, and 89. I'm taking very arbitrary numbers. Now in the first operation, what you will do is you will take GCD with 1, okay. This will convert the array to 1 1 1 1 1. How many numbers are there? 6, yeah. And what you can do is just take XOR with what you will take XOR with 7, okay, and you will be able to get, actually we'll have to take XOR with a different number, not 7 here. So if we have 5, we'll have to take XOR with 4, okay, and this will yield us the number 55555, and that will be a required answer. So this case is ultimate, right? This is going to work in all the cases, giving you the maximum answer of 2. Okay, so that's about the intuition of this question. I think this second case is the important one that many of you might not be able to think right now. But as time proceeds, as you solve more questions on CodeChef, you will be able to find out a pattern like we did. Okay, so this question is a pretty decent question, and I'll just go through the code for you once. Okay, I'll just show you the code so that you people get a better idea of this question. Alright, I hope my screen is better and visible to you people. So I'll just expand this thing. Okay, looks good. Okay, so what I have done is, this part is simply I've taken the input. Okay, I have this, don't go with the macros right now. This is simply the input. Okay, I have made a function where I have to refine my vector or my array. Why am I doing this is because I showed you a case, right, where we have different elements where you have to find a sub array where elements are equal. Like for example, we have 2 2 2 4 4 4 4 and then again 2 2 2. So you have to apply operations on these 4 elements, right? Let's say I'll give you a better explanation on the top. Alright, let's say this is your array. So you have to fetch these 3 elements, right? So you have to eliminate these right hand side, eliminate these left hand side elements, and you have to isolate this array to work for XOR operation. So what you have to do is you have to refine your vector, and that's what I have did in my code. So I'll just show you the code again. Okay, and I have checked if all the elements are equal. This is the case 1. Okay, this thing that I have highlighted is the first case, that if all the elements are 0, you can directly print 0 in the answer, because it does not require any further operations to make things equal to k. Okay, and next what I am doing is, what I am trying to do here is, in this loop, is I am checking that the refined array that I have selected out, are all the elements in that equal or not. If all the elements are equal, then what I can do is, I can operate all of them together in one XOR operation so that they become equal to k in all its elements, right? So first of all, I'm checking this thing, and this will fall under case 2 that I explained you on the talk. All right. So that's what I am doing, and if that meets our necessity, like I have taken a boolean variable as, if this thing is not holding, as is going to stay true. All right. And if it a is true, we are going to print 1 directly for the obvious cases. The second case is I am taking a new vector, I'm making a new vector for easiness of the problem. Okay, I am pushing all the elements in the refined array with their GCD with k. And why am I doing this is I have to check if I take the GCD with k, are all my elements going to become equal to k? And if that is happening, this is the second subcase of my second test case, of my second case that I explained you on the top. That we need one operation to find a GCD, take a GCD, and convert the entire vector to k, right? So if these two conditions are holding, then we can directly say that we need one operation, right? And if these two conditions are not holding, plus the entire subarray is not equal to k, then we can directly say that the answer is going to be 2, right? I'll just quickly show you if it is working or not. The solution has been submitted in the question itself, and it's working. Okay, I'll have to submit this in practice mode, I guess. Alright, I'll just try and submit this if it gets accepted or not. Okay, so you can see things are getting accepted because that's the edge case you have to search. So more or less what you have to focus on this question is, are we able to think that the maximum of the operation is going to be 2? If you have figured that out, this question is a piece of cake for you people. It's not that tough. A bit of bit manipulation is involved, and nothing else is there in this. So if you people have any doubts after uh, getting to know about this question in any of the test cases that I showed you on the top, or in my code, you are free to ask me, like if you have any problem. I hope you people have attempted this question. Like if you guys genuinely feel that you people were stuck somewhere in this, you can ask me.
So if we did XOR on one element, can't we do GCD on the other element in the same range, in the range?
Uh, I mean, you want to say that if we select a subarray, then we can
Yeah.
partly do XOR and
Yes,
partly
sir.
do GCD. No, no, no,
Yeah.
you cannot do that. Because in the problem, you can clearly see now ki you have to first of all select the subarray. And then you have to choose if you want to do the GCD or you have to do the XOR. Like you cannot do both of them simultaneously. You have to choose one of them for that subarray.
Okay, sir.
And what you are saying to me is partly doing, and that will fetch you two operations, not in single operation. All right.
Okay, sir.
Okay. Any more doubts to anyone? Don't feel shy. This session is for you people. It's best if you take the best utilization of this time.
Guys, if you were not able to like solve this question, it's a really good question first of all. So if you are having any kind of doubt, just ask right now. It's a really good question first of all.
Sir, can we change the values of L and R for each of operation?
Yes, for each operation, you are free to choose any L and R. So it depends on you what you are choosing. L, R, and X completely depends upon you. But if you have chosen that, you can either go for GCD and XOR.
Okay, sir.
If any one of you were able to solve this question, just let me know. This question was a really nice question. And one more thing, I would like to emphasize over constraints part. Many of you must not be giving your side to these constraint things, because on the initial days I also used to commit the same mistakes. These constraints are super important. It is going to give you all the hints of the problem. If you can see that n is lying between 1 and 2 into 10 to the power 5, so this is giving you a hint that you cannot use more than one loop nested. Like you cannot use n square complexity here. That will give you DLE. You can only use O of n in this problem. So you'll have to start noticing constraints now, like maturely noticing what is the demand of this problem. Okay. Rest, I don't think there has to be any other problem, and I'm assuming the people
So,
have no more doubts. Yes.
so when the number of operations is one, in that you took the GCD with K, like we can take any number X now. So how like
Uh, are
GCD
you
with
talking
K?
about this third test case?
No, sir. Means in the solution when when we consider that the number of operation is one, for that we take two cases, na.
Yes, yes, yes.
So there we took like GCD with K. So means how?
Okay, so that's your doubt, right? Okay, let me just take you to the doc once. Just a second. Okay, so this is the case 2 where we have to just find out for the single operation, and this is the case, right, where you have to use only GCD. Okay, so why am I using K? That's your question, right?
Yes, sir.
Okay, so the point is, like, if you are given, let's assume you are given this array 2, 4, 6, 8, and 18. Okay, and your task is to convert it to 2, 2, 2, 2, 2, and 2. Okay, so our k is equal to 2 right now, and this is our array. So what you can do only one operation, right? And in one operation you want that all the elements should be equal to k. So if the GCD of all the elements is really equal to k, I mean GCD with k, like, if I just give you a better thorough explanation here, just a second. Okay, so I'm replacing the array with what? uh, GCD of 2 and k, GCD of 4 and k, and so on, right? So if it is not, I mean, I want this to be equal to k. So it is a must thing that this should equal to be, I mean, the second parameter has to be k. If you take anything else, like if you choose any x, you are right that you can choose any x in the operation according to the problem statement. But what is the wise thing to do? That's what we have to think in this question. Like if you select any k, like if you select 8, the answer might not be same. Like I'll just dry run things for you. If on this same sub array, like for this array, if I use any x, let's say equal to 8, okay. So what will be the answer? GCD will be 2, 4, 6, 8, and 2. Okay, this is not equal to 2, 2, 2, 2, 2. Right. And why did this happen? Because we chose a bad X. Like we did not choose the right thing that was needed to be chosen. If I choose X is equal to 2, things are going to yield the better result. Like we are getting all the 2's. So you have to choose K very wisely. X very wisely. And the best thing was that X has to be equal to K in this problem for this particular sub case. Otherwise, you can just try run on different cases. You will yield different results.
Okay, sir.
Uh, is that really clear now? You can ask if it is not.
Yes, sir. It is clear. Thank you.
All right, great, great. If anyone else has any question or any query, you can just let me know immediately. Otherwise, we are moving forward now. All right, so I'm assuming that no more queries are there from your side. Okay, so let's move with the solution for the next problem.
Okay, guys. Yeah, definitely GCD is always is a really great question. So if you haven't been able to like solve it, so after like going through this session and the solutions as discussed by Ansh, I would like insist you all to like go through that question again and try it by your own self again. Okay. So yeah, moving on to the next question. The next question is a really great question. It's triangle count easy. So I will share my screen. Okay, guys.
Hello?
Ansh, you are on like yeah. Okay. Kritik, can you verify just my screen is visible to all? Okay, thank you, Kriti. Okay, so guys, let's go. Okay, so before discussing the next question, that is triangle count, we have to understand one thing. It's a very fundamental concept that's called the triangular inequality concept that we have discussed in our 10th class or like in our like 10 plus 2 and all time. So what does the triangular inequality say is that sum of the two sides of a triangle is always greater than the third side. So let's say we are taking A plus C, that is this side and this side. This side sum will always be greater than the third side. And using this condition only a triangle can be formed. Like if it is a valid triangle, then definitely it will follow this condition. Whether it be in the case of A plus B have to be greater than C, or whether it be B plus C have to be greater than A. In all of these cases, this all three conditions are very much possible if it is a valid triangle. If this our triangle is a valid triangle, so then definitely it is going to be possible for us. Okay, now after we have gone through this, so like one thing I want to say this, that in code forces or like maybe in CodeChef or any kind of competitive programming platform which we are dealing with in day-to-day life, if or we are practicing in day-to-day life, some concepts are really important. Like if I have to mention triangular inequality, it is a question that is coming. It is a small concept obviously, but it comes many a time handy to use obviously. So in this question, it is a very this concept plays a very important role. So if anyone is like not like have forgotten this concept or like not aware, so I would just request them to like go through it once. And even some other concepts also, like there are different concepts regarding of chords, sectors, and even like dividing the whole triangle into half, like 1:3, 1:2 parameter, like kind of things. So I will just like tell them to go through those concepts because they are really important. Those concepts really come in handy at different platform, like maybe at Coder or CodeChef, they come really handy. So, okay, now moving to the next part of this concept. So let us consider a case. Okay, now let us consider a case. Let's put some values on the adjacent sides of the triangle. So let us say we are putting A side as to be a value of 5, suppose. Okay, and let us say we are putting the B side to be a value of 2. Okay, fine. And let us say we are putting the side C to be a value of X, suppose. Okay. So what does we get? Okay, so we will come to this equation later on. It's a very important equation to understand the whole question later on. Okay, so let us say what will happen is that if I go to according to the condition, 5 plus 2 is always greater than X. This is what we're getting. 5 plus 2 is always greater than X. So what we can say, that is X have to be less than 7 because 5 plus 2 is 7. Okay, fine. Now suppose if we say, if we are going to add X this and 2, so what we are getting, X plus 2 have to be greater than 5. Like sum of two sides is always greater than third sides, correct? Okay, so what we are obtaining is that if we just shift this 2 to the other side and just solve the arithmetic operations, what we're obtaining is that X is have to be greater than 3. Okay, so we have got two conditions, and I'm pretty sure that these kind of conditions you have solved in your class 11th, definitely in relations functions. Okay, so what we're obtaining is that X have to be less than 7. Okay, and X have to be greater than 4. Now one thing is that since we know that now over here we're considering that X is an integer value. Okay, we're considering that X belong only to integer, and that too also positive integer. Okay, now tell me one thing, can X be equal to 0? The answer is no. If X is equal to 0, okay, if X is equal to 0, then can't form a triangle. Okay, So one thing we have to know that this condition is very important to understand, that x is a positive integer. First of all, it's a positive integer, and x cannot be equal to 0. Okay, fine. Basic concepts are clear. Now, as per these two conditions, what are the values we are obtaining over here? First of all, x have to be less than 7, x have to be greater than 3. Okay, so we are getting 3, we are getting 7, and somewhere in between we have some values. So what are those values we can obtain? We can obtain 4, we can obtain 5, and we can obtain 6. Correct? Okay, so what we can obtain? We can obtain these values. We can obtain 4, we can obtain 5, and we can obtain 6. Why? Because we have a condition that x have to be greater than 3 and x have to be less than 7. And based on this concept only, our whole question and our approach is going to be decided. Okay. So simply, if I have to just conclude this part, what we are going to say that bi plus bj have to be greater than x. And this equation, or I have to say this inequality, is definitely a very important inequality and is also mentioned in the question too. Okay, so now let's move on to the question part. So let's understand what the question says. Okay, let's briefly understand what the question says. So this is triangle count, and this is the easy form. There is another question that is a hard form as well in today's context. Now, why it is easy? Because of this condition that the problem is for the whole entire array. And what is the problem that we are going to see over here? Okay, so this is the part. Okay, why it is easy. And rest is just an instruction that why 100 points, like 100 points is all given to all the division and those things. Okay, now moving on ahead. So what it says that we have an array, okay, and they have named it as B, which contains basically m distinct integer. Now distinct is also highlighted over here, black and dark black color. Okay, so in CodeForces, CodeChef, or AdCoder, many of the places you will see dark color characters. So definitely focus on those characters very. Like you have to focus on those characters. Like you have to focus very minutely on those characters, because those things only will help you to understand the question very better. Because many times while we're just going through the question and there's too much of things, we many times miss the things, and the problem setters try to attract our focus on these things. So over here, distinct is a very important or peculiar word over here. Okay, now, so what are the elements? Since we have mentioned in the array B, we have m elements, so we are getting b1, b2, and so on bm. So we have m elements, and these all elements are what? Distinct. Now they have defined a function. What this function says is that, so they have defined a function, and this function f of b, which is taking what? Array B as an input. Okay. What is it says that it will give us the number of distinct integer that will satisfy the following condition. Okay. Now what it actually says that we have to find this value actually. This x we have to find. And what will be the input of this function? B will be the input. Now, what we are asking is that we have to find a value x such that it satisfies such that certain conditions are satisfied, and these two are the conditions. First, x have to be greater than equal to 1. What we are actually choosing is x, first of all. And why I have mentioned over here x, you might be like kind of relating the things. We'll start relating the dots now. Okay, so what they're mentioning that we have to find x, and x have to be greater than 1. Okay, and what is the condition that we can take two values I and j from 1 to the m. And what is 1? Like 1 to m is basically the range of this array B. Okay, as here mentioned. Okay, now such that the possible like we are obviously possible to like form a non-degenerate triangle. Non-degenerate triangle is basically a triangle which have an area not equal to 0. Okay, non-degenerate triangle. That's why I mentioned like basic mathematics have to be cleared. Even in our introduction session, we are mentioning basic mathematics, class 10th, 11th, 12th, basic mathematics, coordinate geometry have to be cleared. Okay, it should be clearly like you should have at least a good concept over in these things. So non-degenerate triangle, it means area should not be equal to 0. Okay, and this triangle should have the length bi, bj, and x. So suppose this is a triangle, so it will be b of I, it will be b of j, and it will be of x. Okay, as I have mentioned over here, say 5, 2, and x. Okay, great, good to go. So till now I don't think any issue is there. Okay, and even they have also mentioned what is a non-degenerate triangle. Okay, Fine. Now, what we have to find is basically the x. Okay. Now, if we have to find the x, can this relation be hold true? Tell me, like, can this relation be hold true? That if we are considering a given side like this, a given side is x and other side is bi and bj, then definitely bi modulus of bi, obviously, just to hold the whole inequality true, modulus of bi plus modulus of bj have to be greater than x. That is, sum of the two sides of a triangle have to be greater than third side. Fine, good to go, right? Okay, so what are they saying is that we have to just find x such that x have to be greater than 1, and it is forming a triangle with bi and bj, which is a non-degenerate triangle having an area or positive area. And to have a positive area, the triangle have to be an adequate triangle, and if it is an adequate triangle, it will follow what? Triangular inequality. So if it is following a triangular inequality, then it is a non-degenerate triangle, we can say this thing. Okay, fine. Now, if we move on further, there's something mentioned about the input formats and the output. So output, they are just asking like, what should be the value of f of a, and that's nothing but what are the values of x. Okay, what are the values of x? Fine. So they are asking about what are the values of x. So again, I will just give a recap. If we have a triangle with a side of 5, 2, and x, and if you have to find the x, so then x will be in the range of what? 3 to 4. Okay, and the values would be what? It will be 4, 5, and 6. Fine. So in this way, we can find the values of x, correct? So this is mathematical intuition which we are developing over here. Okay, so this is mathematical intuition which we have developed. Now moving ahead, if we further go, we have to given is what? The input. We have given a task is t, then they have given us the size of the array, where size is what? That the b array that we have mentioned over here, this one, the array b, which contains m distinct element. Now they're just mentioning that we have like what? N elements. Obviously the n elements are going to be what? Distinct. So okay, now what we have to do is that we will choose two values, that is I and j, or maybe say a1 a2 or a1 a3, or say ai aj, and we will have one x. We have to find that x, what are the possible values of that x for that particular ai and aj, and that is our, and we have just accumulate all those values. And while accumulating, we have to make one thing very, very sure is that x have to be distinct, because in the question they have asked number of distinct integer x. They are not asking just randomly just sum it up. But like there can be possible cases now where ai and aj, or maybe say ak and ap. Okay. So they will have suppose values of x differently, and they can have some overlapping values. So those overlapping we have to ignore. Okay, so what we have to do is that we have to kind of find the union kind of thing. Okay, so this is very important. So this is very important that x have to be a distinct integers. So we have to find the total number of distinct integer x that can be obtained if we are picking ai and aj, and based on this relationship, the inequality, we're going to find those things. Great. These two cases are very, very important, and that is ai and aj can't be equal. They have to be different because they're distinct values, and we can't pick ai and ai again 2 times. So those cases have been replaced. We can't pick same number. For example, if we have 5, 2, 4, like consider this case only, 5 to 4 as a triangle values. So we can't pick 5 2 times. So that thing they are mentioning over here. Okay, so okay, fine, moving ahead. I think till now everything is like clear only, because we are not discussing something really hard. Till now we're talking about 10th or like maybe 11th class mathematics over here. And later on, what they have said is the I should not be equal to j, and we are talking about that is all the test case should not exceed 2 into 25. This is the general standard like constant that are given in the CodeChef or maybe in Codeforces. Even many a time in the ad code you will see these things. And these are some input values. Okay. So we will now discuss some input values. Based on that, we will understand the whole concept and our basic intuition for this question. Okay. Give me a minute. Okay. So we are taking one case, that is this one, 5, 2, and 4. So in the input, they are given us what? T test cases. So this is T, and for every test cases, they are giving us n, the size of the array, and then they are giving the elements of the array. So we are just picking an array which have 3 elements, and the elements are 5, 2, and 4. So over here, so we have what? We have 3 elements, that is 5, 2, and 4. Okay. So what we have to do is that we have to found an x. Now, what I will just, like, this is a very important thing you have to understand in any of the platform, is that when you're getting a question, the question could be a very, very large questions, bunch of things will be put it there. Simply short the question. Now I'm going to short the question and put it in a single line. We have to simply pick 2 values, and each value in this array is a side of the triangle. So we have to pick 2 values, and based on 2 values, we have to found distinct x. And after picking all the pair of twos, after picking all these pairs of sides, we have to club all these distinct values of x, and then we have to see what is the total number of distinct x we are obtaining. This is the simplest form we are going to understand this question. Okay, fine. Now if we move further, what we have to do is that let us short the thing. One thing that you will learn bit later is that, or maybe many people you know, that shorting is a very interesting thing to do in question. Like if you short the thing, if you short the data, many a time you will like reduce your, like, the whole question to a very simpler format where you're able to understand things. But yes, you can't short always. You, like, if the condition supports you, then only you have to short. Like in this case, the shorting is allowed because you have to pick any 2 random numbers. It's not that you have to pick adjacent, or it's not like we have to just pick first and the next to next element. Not that kind of thing. We can pick any number. So obviously sorting is in our hand, so we have shorted the element. Good to go. Okay, so we have sorted the value. Good to go. Fine. Now over here, before moving further, I will again take you to the example. So for finding the x, we have deduced 2 things. For finding the x, we have deduced 2 things. What is that? So if we have 2 sides, bi and bj, if we have 2 sides, bi and bj. So let me just clean it for you. Otherwise, it will be too messy for you to understand these things. Let me just clean it for you once. This is not required now. You understand? Okay, good to. Okay. Now, if you focus on this thing very good. So based on this inequality, we are going to find the range of x, correct? And this range only we are going to incorporate in our this value. So if you clearly understand, what we have obtained is that we were talking about 2 things. That is 5 plus 2 is greater than x, and we were talking about x plus 2 have to be greater than 5. So what we are getting is that simply what we have to do is, for obtaining x, is that we have to first add the 2 sides and subtract the 2 sides. Correct? In this case, like, we are subtracting the 2 sides. To get the minimum value of x, we have to subtract the 2 sides. And to get the maximum value, we have to what? Add the 2 sides. So let me just put it here. So to get the maximum of x, we have to add the 2 sides, and to get the minimum of the 2 sides, we have to subtract the 2 sides, keeping in mind that we are taking only the absolute value or the modulus value. So let's use mathematical terms over here: modulus or absolute value. Okay, fine, good to go. So this is the value you have to understand. So you have to just say x is something which is belonging from sum, comma, sorry, my bad, it's belonging from difference, comma, sum. And let's make it more mathematical. So I'm over here using is that we have to just not include the difference, obviously, because it have to be greater than difference, and we are not including the sum because it have to be less than the sum. So based on that, we're not using the square brackets, we're using the round brackets. So we are not including these two terms, like difference and sum we are not including. We're just including the next term after the difference and next term and the before just before term uh, the sum. Okay, so this is the range of x. This is the range of x we're talking about. Okay, so this part is clear. This is the range of x. Fine. Now let's focus. Now what we have done is that our main part is done. The main thing, the main concept we have reduced. The main concept is done. Is that we have to find out the difference and we have to find the sum of what? Of each of the pair which we are going to find. Okay, good to go. Good to go. Now, for example, let us take for this case, we are getting 2, 4, and we are getting 5. Okay. So if we just take two adjacent values, suppose what we are obtaining is that 2, 1 and 6, 9. Correct. I'm just taking two cases, 2, 4 and 4, 5. This adjacent values I'm taking. Okay. Even there can be possible cases of 2, 5. Okay. So this that can also be possible over here. So I'm just not taking that case right now. Okay. And not taking that case is also a very valid reason why I'm not taking that case, because, and there's a valid reason. Okay, so till now I think it's pretty much clear that what is the basic intuition for this question. We are going to use triangular inequality. We have this bunch of inequalities questions. We are the range of x we are going to find by this condition, and the range of the x is in the range of like difference to sum. Good to go. Now the question arises that how are we going to pick the values, like on what criteria we're going to pick these values, like which two values, or so in this case obviously we're going to pick all of the values, all of the two pairs, like we're going to take. So in a brute case, if you're picking the values, it will be obviously what, O of n square, and obviously the code won't run. It will give you TLE. Why? Because the constitution not 2 in 20 to the power 5. It won't give you that that luxury to use O of n square code. If you will able to use O of n square code, then the thing would be pretty easy to good to go. Okay, so yeah, so till now we have found x. Fine. So let's now move to the actual logic of this question and what we have to do. So why we have sorted is basically a reason. Now, if you clearly understand what actually happened is that we are picking two values. Okay, what we are doing is that we are picking two values, and based on that values, we are finding our x, and we are picking just two values. Okay, two values we are picking, and based on that, what we are finding the x, and based on that x, we are finding a range. We are forming an what interval. We are ranging from small value to we are ranging from different to some, and this interval, there will be a lot of intervals, and what we will do, we will just simply plot them on a number line like this, and connect these values like this, as we were doing in the 11th class, as we have in relations functions. So if we clearly understand this part, and what then we have to do is simply that we have to just add these values, like the distinct values. So I will just draw it once for you to just visualize it. So let say we have lots of number values. What we'll do is we will just simply plot these intervals, and we will have our what values in this. They can be overlapping values too. There can be a gap too, and a lot of stuff. Fine. So what earlier I was doing in this question was, and it was not a good logic, and because of that I was not able to pass certain cases. Later on, which I recognized that, and many of the people who were like solving this question could not solve, or maybe they have come till this far, I was not able to solve. The issue was that you people were like many people were thinking that we will just simply find the maximum value that is over here. That is simply the sum of this, that is 9, and the difference of the first two element or the first two values or the minimum two values, and that's giving us what 2, and we will just take the range of these values, which is simply what 3, 4, 5, 6, 7 and 8. Correct. And based on that we are getting the value. Okay, and that output is coming to be is what if you have to just take like 5 to 4, it's somewhere If you take all the cases, it's hello. I'm audible, na guys. Just no interruption.
Yeah.
Okay, okay, okay. Good to go. Good to go. Okay, so yeah. So what I was talking about is that we have 5, 2, and 4. We have shorted the thing, and based on that, what we have obtained is that we have a range of 2 till 9. The minimum value can be 2 of x, and the maximum value can be 9. Fine. Now, if you clearly understand this logic, there is a lot of things which are missing. Like if you just clearly observe this value, there are a lot of things which are actually missing. Like this data in my logic of this, there were this whole data was missing, and this data was missing, because when you are adding the thing, you're just going to the extreme values of 2 points, and you're getting all those values. But actually, you should not have to consider these values. You have to deduct these values, and this was the actual logic which actually took a bit time for me to understand, and but later on I got to know. So let me just rub this value and again explain the later part what I have done and what should be done in this question. Okay, so if we clearly understand, so what we have is that we have 5, we have shorted the value, we have put 2, 4, and 5, and if you just plot these values on the number line and the difference, so the difference values we have obtained over here. Okay, so what we can do is that okay, so what we can do is over here, so we can just put these values in the number line. So the minimum value in this case will be what? The minimum value in the difference, if you just look, it will be 2 minus 4, or 4 minus 5 minus 4, that's 1. So just say the minimum value is going to be 1, and the maximum value we're going to obtain is that what? 9. So earlier I was using this logic, and it's not a good logic to go with. So later on what I deduce is that, let me just rub it so that there's ample space. So later on what I actually got to know is that we have to first short the value. Earlier I was not sorting the value, just picking values. So what we have to do is actually we have to short the value, and what we have to do is that we have to adjacent, sorry, my bad, and then we have to produce these values. What actually we have to produce is this: 2 plus 4 is what? 2 plus 4 is 6. Okay, and the difference of them is what? 2. So if you're picking these two elements, the range will be 2 to 6. Okay, fine. When we are picking the next value, that is 4 and 5, the difference will be 1, and then we're getting 9. Okay. Now you might be thinking why we're not picking 2 and why not picking 5. So this will be pretty clear if we move further ahead. Like if you move further, you will get to know that why actually not, because there was lots of cases where overlapping was going on. So that is the reason I have not considered 5 and 2 as well. Okay, so we are getting difference 2, sum 6, difference 1, sum 9. Fine, good to go. So if we clearly put these values on the number line and analyze those values, we will get our required values. That is, sorry, my bad. I was putting on 15. Sorry, it's 7 actually. My bad. Sorry. It will be 7. Okay, so this 7 we will obtain, correct? So how we will obtain? Let's see. If we put the values over here, so this is what? 2. Over there we have 1. Okay, sorry, my bad. I missed one more part. And actually there's a lots of thing actually going on, which small thing which we have to take care, otherwise you won't get the value. Otherwise there will be lots of issue. So now we have obtained the difference and this value. Now when we are plotting these values, are we going to take this 2? The answer is no, we are not going to take 2. What we are going to take? We are going to take 3. Are we going to take 6? We are not going to take 6. What we are going to take? We are going to take 5. Are we going to take 1? No. What we are going to take? 2. Are we going to take 9? No. We are going to take 8. So let's put them. So if we are putting this value, we are getting what? We are getting 2. We are getting 3. We are getting 5. And we are getting what? 8. Okay. we're getting 8. Now if we just simply calculate these values, so we will get our range. So what is the range value? This is 3 to 5 and this is 2 to 8. So if we just deduct 2 to 8, we are getting 6, and obviously deducting 8 to 6 will what? Remove 1 point. We can't remove, so it will be simply like 8 minus 2 plus 1. Okay, 8 minus 2 plus 1, because this will give us what? 6. 6 plus 1 is equal to what? 7, and that is our answer. So this is clear. So this way we are obtaining the 7 value. Simply putting this value on the number line, and based on that we're just clubbing, we're just putting our like lower limit and the upper limits, and just based on that we're counting all the numbers which are in between and including those numbers too. Okay. So this is part is clear. So this is the basic mathematical intuition for this question. And what we have to now, while you are now, since basic mathematical intuition is good to go with, but the main issue was actually with this thing, that while picking the values, like how many times and which are the elements we're going to pick. And not only that thing, but there is another issue, is that how are you going to tackle like which interval to pick or which interval to not pick. There's a lot of things. So for that we have a like, this is a standard way which I like generally I use, is that if there's an upper limit, okay, let's take again I will just draw this value. Okay, if there is an upper limit, say 2 3 5 8, so 2 we are getting 3, we are getting 5, and we are getting 8. What you should do is that if there is put lower values as plus. Okay, so yeah, lower values as plus, because 2 is lower, 3 is lower, 5 is upper, and 8 is upper. What you will do is that if you're using this logic where we are putting lower values as positive and upper values are negative, so and after that if you're just counting this adjacent value, this value, now we're not going to like 3 to 5 or 2 to 8, which is actually the interval. Now we're just counting 2 to 3, 3 to 5, 5 to 8. But there will be a variable that will be let us know that if there is a check condition. Okay, this check condition will help us to know if this value is positive, then we will consider this value. Then we will consider this interval. Simply we will minus these values, and whichever the term in between and including these terms will include those values. If this value is less than or equal to 0, we are not going to include these values. So what actually happens in this case is that since we are moving from positive to negative, and at the last the whole term is going to be a 0 or less than 0, so that is actually the reason why this whole interval was selected. Now let us take another illustration. Now if there is a case where we started with negative and then we are moving to positive, okay, then we are not going to consider this, and it's not a valid case even, like, correct. Another case would be what? If we have positive, negative, lower limits again, but that's not possible. We should at least have 2 positives to have 2 negatives. Okay, so that is the point I'm talking about. So based on this, like this basic mathematical intuition, we are going to pick our values. Okay, another illustration for this question is this one, and it's a very good illustration. And yeah, here is the test case. This one I'm mentioning is 5 to 4 and 12. If you just find the difference and the sum of this pair, you will reach over here. That is 1, 3, 5, 6, 17, and 15. These are the, I think, oh sorry, I just took the wrong example, sorry. We are talking about this example, 3, 1, 6, 5, 50, and 17. So if you just take this example, so what we are getting the range, 3 and 4, 3 and 8, 2 and 11, 12 and 23, and 34 and 67. Why 3? Simply this value, like 3 minus 1 is what? 2. We have to take greater than that value. So that's 3. And we're taking 4. Actually, like in the later part while I was mentioning over here, so there was one thing is that we were also adding this one. So like to just overcome that adding 1, I have just increased the value of the upper limit by 1. Like we are not reducing it. We're just keeping the upper limit as it is. Okay, so that we don't have to encounter this taking like 1 again and again. So 3 and 4, 3 and 8, 2 and 11, 12 and 23, 34 and 67. Okay. Now what we're obtaining is that, as I've mentioned, we'll just put the lower limit with plus. So lower limit what? 2, 3, 4, 8, 11, 12, 23, 34, and 67. Good to go. Lower limits will plus. So 2 plus 3 is coming 2 times over here and over here as well. So 2 times plus. Then 4 is minus, minus, and again will go. Now if if you just go through this diagram, you will get to know that we are putting a check function. Till this check function is positive, we will simply take this interval. We will take this interval. We will count this interval like this way. And if it is less than or equal to 0, we are not going to count this interval. We simply just reject this interval until and unless this is positive. Now you will consider, you will be thinking like how this is like converting like positive and negative. So in the code, it is pretty much clear. So now let me just take you to the code, because I think the whole mathematical intuition part is clear. Like till now, anybody have like doubt like what is the mathematical intuition behind this thing? Guys, do you have any kind of like doubt for this? Like till now, the mathematical intuition, I think it's pretty clear. I've explained a lot, like too much I've explained. Okay, good to go, Bharat. Any more like anybody else like? Okay, fine. So let me just move on to the code part. It will help you a lot in understanding. So over here we're just taking long. We will be cautious. Otherwise, int will be also be good to go. So just for a precaution, I've taken over here long. So input I've taken, the whole array I've taken, and as I was mentioning, I will just short the whole thing. Now what I have done is that, as I have mentioned you, we will put the difference plus 1 and the sum value. As I was mentioning earlier, that the value should be what greater than the difference, and what should be equal to the sum, because we are adding one was additionally added to take that care. I have just removed that reduction of 1 and just keeping over here. Like, this part I think is clear, like mathematical part is clear. So I'm just putting over here is what difference, and then it's the sum part, and I'm just putting it into what a vector pair. Then again, what I'm doing is short. Now, what I was earlier mentioning is I was putting like how we are going to consider that plus and minus. So this is the way how you're going to do the plus and minus. So if it is a difference, I'm going to just give it a plus 1, and if it is a sum, I'm giving it a minus 1. And then what I'm doing is finally again short. Now, if you were not shorting the thing and just going to the whole classical thing, then definitely you would have like ended up time limit exceeded, or maybe like the whole thing would be giving a wrong answer. So this approach actually gives a very good understanding like how the things are actually going on. So putting like plus and minus, it gives a really great understanding, and even like it's visually appealing and visually like understanding good to go there. Now what we're doing is that, as I mentioned, we'll put a check condition. We'll put a previous element as -1. You can just put any value. It's not, I just put it -1 because all the terms are positive over here. That's the reason I put it -1, but you can go with any value, preferably negative only, because then only you're going to like compare it to those things. Okay. And then we're putting total sum is equal to 0, and total sum is the actual like final value of x. Now after that, what we have done is that we have just simply moved, like we have just gone through all the elements. Okay, like after we have shorted the whole elements, in this case, like after we have shorted the whole elements, this is shorted 1. Okay, so what we have done is that we're going through all the elements and picking the first value, that is the lower limit. Sorry, no, my bad, sorry. In the event, when we shorted the event, we have two values. One is the value and the other is the nature of it. So one is the current value and the type, whether it's positive or negative. So based on that, if it is like positive, okay, now if it is positive, we will add the value to the check type, and if it is negative, we will again add the value to check. So as you can see, the check is updating regularly, like it can be like it is increasing and decreasing as well. So based on that condition, we are going to consider this interval. Now if the check is coming to as negative, then we are not going to include this. If check is coming to be positive, then we are going to include this interval. Okay. Okay, now finally what we are putting is that conditions is check have to be greater than 0 and previous element should not be equal to -1, which was a preliminary condition, and we are updating our previous element. So what is actually happening is that we will be starting with 2. 2 is what active value is what like initial like check condition is what 0. So we're not taking consideration. We'll move on to the next value, that is 3. Now active value is what increased because type was 1 only, because this value was plus, so it has increased. So here we have increased, like plus is there. Now what we'll just do is that we'll simply like we are going to consider this interval because we have passed these check conditions, and finally what we do is add. Now, finally, like if you just go through this part again, it will get more clear to you, because coming up with this logic of plus and minus, I think it's a bit tricky because it's totally mathematical intuition based. So might be we will not be able to like get to hint at the exact moment of the contest, but later on I think it's pretty intuitive. So this is the overall solution of mine. I will share all the things, like we'll share all the things with you in the group. I think it's pretty much clear to everyone. So now let me know if there's any doubt, like if anybody have doubt. Uh, like, but like, do you have any doubt, or maybe Mamta or anybody else? Like, is it clear to you? Or...
No, sir. No doubt.
Okay, okay, got it, no issue. Okay, so just like I would say that just go through the mathematics part once again, and it will be like clear to you all. Okay, and rest we will share all the things to you in a more documented form, so that it for revision if you required you will get it. Okay. Okay, Bharat. Okay. So there was another question. Yeah, there was another question which was known as count winning subarray. So it was really like less in number, like less number of people have like solved this question, that question. And even like I have also asked in the chat, like nobody have like like solved that question. So currently, like we are ignoring those, like just leaving that for discussion. If anybody like required the solution and those things, so do let us know. We will share it in the group. Okay. Hans, I think we are good to like end the session because it's already too late.
Yeah, it's almost going to be 1 a.m.
One, yeah.
Yeah.
We can stop the recording, right?
Yeah.